while we talk a little bit about our first topic tonight. Our first topic is, well, first off, our first speaker is Jim McQuillan. He's a longtime member and board member of the Michigan Unix Users Group. He'll be talking a little bit about universally unique identifiers, what they are and what they are useful for. So take it away, Jim.
All right, so let's see. We already tested my screen sharing, but I want to get a different screen. There we go. Okay. Share. Okay, are you guys seeing it? Because the way my screen works, I don't see it. So you see my slides, right? So I'm going to hit play.
We have them now, yes.
Yeah, I gotta play. Okay, so there we go. As Craig said, universally unique identifiers. That's what I'm talking about tonight. What is a UUID? Randomly generated 128-bit value that is highly unlikely to be duplicated. Also sometimes called a GUID. I say randomly because there are some cases where it's not. So you'll get the little star next to randomly. And highly unlikely means that when you are doing random UUIDs, they are very, very, very likely to be unique throughout the universe. And I'll get into that in just a second. And what I've got there is a UUID. That's what they look like. They are in the format of 8 bytes, 4 bytes, 4 bytes, 4 bytes, and 12 bytes, or 12 digits, I should say. I'm calling it bytes. They're 12 hexadecimal digits. So let's see, how do I do next? So a little bit of history. This is real brief. They were first recorded as being used in the 80s by Apollo computers for their network computing system. The Open Software Foundation adopted them for their distributed computing environment. Microsoft adopted them for their Windows operating system, but they gave them the name GUIDs because Microsoft just can't leave well enough alone, right? And in 2005, there was finally an RFC describing them, published by the IETF. Let's see. Here's the format, and like I said, it's 8 digits, 4 digits, 4 digits, 4 digits, and 12 digits. Those groups of digits mean something, or they have some meaning. Initially, this is what they were used for. Okay, all of those that say A, the first set of numbers is the low 32 bits of the time. The second set of numbers is the middle 16 bits of the time. The third is it's a 4-bit version number and 12 bits of time, and then the fourth chunk is 1 to 3 bits of a variant, followed by 13 to 15 bits of a clock sequence. I'll explain what that is, and then 48-bit for a node ID. Now, when you look at this description, it doesn't look all that random. It's based on time, and it's based on a node ID, and there's still some randomness to it, but it's kind of based on those things. Where's my mouse? No, there we go. Okay, there's several versions available, and understanding them will help you choose the right version. I learned about this because I needed to use some UUIDs in my software, and I thought they were just a string of digits that had no meaning, but I was wrong. There are different versions for different purposes. The first version is the date, time, and the MAC address, like I described in the earlier slide. The second version is kind of like that, but it's called the DCE security version. There's not a lot of information about just what that means, and almost nobody uses it. Version 3 is the namespace. It's a namespace. I'll explain just what it is in a sec. 4 is really a random UUID, and 5 is another form of namespace UUID. So version 1, you can see here the layout. It's a 60-bit timestamp. It's the number of 100 nanosecond intervals since midnight of October 15th, 1582. That's a long time ago, so the dates can go way back. It's also a 13 or 14-bit clock sequence to handle cases where the UUIDs are generated. I'm sorry, I got to figure out how to get rid of this Zoom window that's popped up that's kind of covering up part of my slides for me. You guys see my slide. I see most of my slide. Anyway, the clock, the 13 or 14-bit sequences to handle if you're generating more, if you're generating lots of UUIDs in the same 100 nanosecond time slice. So anyway, with that 13 or 14-bit sequence, we can handle up to 163 billion UUIDs per second per node. That's a lot of UUIDs. And it's followed by the last field is the 48-bit MAC address of the node. And I'll show you in a little demonstration exactly that is what it is. The problem with version 1 is it can be tracked back to the node because that last 48 bits is basically the MAC address of the workstation or the node that you're using. And you can track the date and time because that's embedded right in the UUID. Could be a privacy issue if you're concerned about those things, depending on what you're using it for. Version 2 is pretty much the same thing as version 1, but they've actually taken away some of the clock sequence and the timestamp for you to fill it in with a string. It'll end up being a hashed string or a coded string, but it's maybe less random. Maybe gives you a little bit more control over what it is. In this case, where the clock was ticking every 100 nanoseconds that was version 1. In version 2, the clock is ticking every 429 seconds. So that's a little over 7 minutes. It's a little bit weird. I'm not sure why anybody would ever want to use this. Most implementations don't even include it. Version 3 is a namespace name-based. Basically, you take a namespace and there's a set of namespaces defined, and you take a string, like maybe a URL, and you concatenate them together. You hash it with MD5. You replace a couple of bits so you have your version and your variant, and that's your UUID. The problem with that is it's not random. You can, if you call the version 3 function with the same parameters, it's going to generate the same number on that machine and on any machine. So it's not unique at all. It's just a way of getting a UUID value from some string you have. Version 4 is really where the good stuff is. Version 4 is random. It's got the same 4 bits for the version, 2 bits for a variant, and 122 bits of randomly generated data. You can see in my notes there, that's 2 to the 120 seconds, or 5.3 times 10 to the 36, or 5.3 undecillion possible variants, possible UUIDs, variant 1. If you go to variant 2, and the variants, all they do is dictate the whether the numbers are signed and the byte order of the various components. Remember big endian and little endian and all that stuff. Anyway, variant 2 is half as many, so it'd be what 2.65 undecillion possible V4 variants. You guys all familiar with the birthday problem? You may have heard of this before, where how many people need to be in a room together for 2 people to share the same birthday, or for the chances to be better than even that 2 people will share the same birthday? And the answer to that is 23. You take 23 random people, put them in a room, and chances are they'll share the same birthday. Now, not the same year, but if your birthday is May 1st, you got 23 people in the room. There's a 50-50 chance that there will be somebody else in the room with a May 1st birthday. So they use that to determine what's the probability, how many UUIDs do you need to have generated to have a 50% probability that that there's at least one collision? And the answer is 2.71 quintillion. That's, I don't know how many zeros. It's a lot of zeros after 271. So it takes an awful lot of these things in order to find a collision. Put it in perspective, you'd have to generate 1 billion UIDs per second for about 86 years before you stood a 50-50 chance of hitting a collision. This two numbers with the same thing. Version 5 is just like version 3, only they use SHA-1 for the hash instead of MD5. It's the same damn thing. Let's see. I've got some examples. This is where I have to get out of my app. Can you guys still see my screen? I've got some examples. So, can you guys see that screen okay where I'm typing? In fact, let's. I'm going to show you some program samples first before I get into the.
You're showing the screen with the examples, but no examples showing.
Yeah. That's because it's still sharing. I don't want it to share that. I've got to stop sharing for a second and share something else. Thanks, Bill. I want to share. I think this is the one. Oh yeah. Okay. Can you guys?
Yep.
Do you guys see a small Python program?
Yes. Yes, we are.
Okay. And the font size is okay and everything?
I'm seeing it just fine.
Okay. So this is a really, really simple Python program, right? You import the UUID module, which is a standard, it's part of the base Python. And you run the UUID, this is to get the V4, the version 4, which all I ever use is version 4 because I want really random. So this is the function you call to get a UUID version 4. You got to call the string function. You got to wrap it in the string function in order to get that string, because normally it's 128-bit value. If you want to represent it as a string, you got to call str on it. So that gives you a string, UUID string, and we print that. So let me just run it. And there's a number. And there's another one. Okay. I know that these are version 4 UUIDs because of this digit right there. See that? That 4. The first 4 bits of the third group of numbers is the version. The first 2 or 3 bits of the fourth group of numbers is the variant. Okay, and the variant, I think, is 10 on all of these. There's basically variant 1. Variant 0 would be 00. Variant 2 would be 11. It's actually 110. So anyway, we're spitting out version 4 variant 1 UUIDs. So that's the Python program. Let me show you a quick example of how to do it in Perl. Again, it's really simple. You just you use the UUID package, which you have to install. It's not part of the base Perl. It's just like Python, though. You call the UUID function, and this generates a version 4 UUID. UUID Perl. And again, you can see I'm generating a version 4. Variant I know that hexadecimal B is 10 something something. Some of you guys probably know that better than I do. So anyway, I keep generating nice random UUIDs. So let's see. I got to share a different screen now to show you some SQL examples, because that's where I do all my stuff. Let's see. Shrink this down the right way. Stop. And I'm going to share again to give you a different screen. I think that's the one this time. Yes, that's the one. Okay, so I'm in Postgres here. And I can run some examples. I think, yeah, I'll run the examples. So so here's a simple one. We'll generate a version 1 UUID. All right, so I just call UUID generate v1, and that gives me this UUID. And you can tell that that's a version 1 because of the first digit of the third set of numbers. I'm going to paste this next snippet in. I'm going to generate a bunch of them to show you. See what I have? This number is my MAC address. It's always the same on every time I generate a UUID. It's always the same number. This number is the low order bits of the time. And you can see it does change. And the time is 100 nanosecond slices of time. So you can see that it's changing, right? A little bit. This number is the middle 4 bytes of the time. 4 bytes, 2 bytes of the time. 16 bits of the time. This here is the sequence. You see it going up one at a time. 860A, 860B, 860C, 860D. It increments by 1 every time. If I run this command again, you can see that my first digit's changed because it's for the low significant digits, and my sequence number just picked right up where it left off. 8, 6, 14, 15, and so on. So you can see version 1 is, you can figure out the time, you can figure out the MAC address, so possibly you could locate that node out in the world. So it might be a privacy issue. I'm going to jump next to version 4 because that's the one that I like to use. You see that? And I run this command as many times as I want, and it's going to be a vastly different number every time. If I do the same thing where I run 10 of them real quickly in a row, see, they're all different, other than the first digit of the third set of numbers is always a 4. And the fourth set of numbers, the first 2 bits is always the same. Everything else is just random. So it's a good way to go. I'm going to talk real quick about version 3. This is what it looks like in Postgres if you want one. You have to pass it, you have to provide a namespace UUID, which this function will do. And you have to provide it some string like a URL. So I chose mug.org as the URL. And that's the number that it produces. You run it again, it's exactly the same number. If I run 10 of them, they're exactly the same. So I don't know what use the version 3 is, why you would want to use it, unless you're just trying to use it to identify something that you have great control over.
I think it'd be more for creating unique identifiers based off of different bits of text. So you could use it kind of like an MD5 sum or something like that.
Yeah, but yeah, and if you need to store it as a UUID, fine, you can do that.
Yeah.
Otherwise, I would just use an MD5 sum or a
SHA,
SHA1, right?
It could also be used to do a hash key. If you have something you're storing in a hash table,
Right.
you can use generate UUID as a unique identifier for that.
Sure, but why wouldn't you just use the hash itself? I don't know. Anyway, version 5 is much the same. The only difference between 3 and 5 is they're using SHA1 for the hash function instead of MD5.
We do have a question from Justin. Justin,
yeah, Justin, go ahead.
Hey, yeah. Do you know, maybe this is a crazy question, is since you provided that like URL or any other string, is there another function to decode that from?
It's a one-way. You
Okay.
So
it is like a hash. Yeah.
Yeah. You can't take this number and figure out that it's mug.org.
Gotcha.
Right. Because part of the process is to hash what you have. This thing here, in fact, if I run select UUID NS URL, it's going to spit out UUID. So the version 5 function, you have to feed it it's a version 1 UUID. One of the parameters you have to pass the version 5 function is a version 1 UUID and a string.
Cool. And another related question: do you are these functions built into Postgres or are they custom? Or
no, I'll show you that in just a second.
Cool.
I've got it on a slide. We'll go through that real quick, but there's I'll show you how I use it a lot. I'll create a table. See, I'm going to create table where I'm setting the ID with the default value of a version 4 UUID. If I do that, I just created the table. And you can see my table has an ID column that is it'll automatically fill in with a V4 UUID. So I can do things like insert into my table, description, value, this is my value. And if I select star from my table, see, it automatically generated this UUID as my primary key for my table, as my ID. I do that quite a bit in my software where I need to have a unique ID for records that I'm inserting. So let me switch back to my slides. We can cover that. Let's see what's this one. And let's go big. Here's a slide with the Python example. I'll give Craig my slides so that he can put it up on the website and you can see what I have there, so you don't have to watch the video later if you don't want to. That's the Perl version. These were the Postgres. This is for Postgres version 12 and earlier. You had to use the extension, the UUID-OSSP extension, in order to get these functions. Postgres 13 and onward has gen random UUID built in, and it's a V4 UUID. So you can just call that function instead of, well, again, I can't use my mouse here. Instead of the UUID generate V4 function, you can just use gen random UUID. I still got some customers that are running Postgres 12, so I'm still sticking with the older extension to get it. But in the future, I'll be able to switch to just the built-in function. Let's see, MySQL, that has a UUID function, but it's version 1 only. And searching through Stack Overflow, there's all kinds of people with all kinds of crazy ways to generate a V4. And then, of course, as typical with the Stack Overflow, there's all kinds of people talking about how that way is bad. Anyway, it's nice that Postgres has the built-in functions that give you the version that you want. Here's some references for you. The RFC, the link to the RFC, if you want to check that out. There's a lot of gory details on that RFC about UUIDs. I got a lot of information out of the Wikipedia article, which is pretty good. The birthday problem I talked about earlier, where 23 people in a room, you'll likely have 2 people with the same birthday. The Postgres UUID docs and the MySQL docs. So, questions? Anybody?
Justin again. Go ahead.
Hey, yeah. We just recently heard about this new spec UUID. I just dropped a link in the chat. And it's kind of interesting. I was curious if anybody else had run into that yet. It's pretty new. But yeah, the L is for lexigraphically sortable.
Oh, really?
And yeah, so they also encode time, but they have like 48 bits, and it's all on the front. So you can sort it by time, basically.
That's handy. That's real handy. My tables where I have a UUID also have a timestamp in another column, and so when I want to find things, I always have to sort by the timestamp descending because I want to see the latest entries that were put in. And sorting by UUID gives you nothing useful.
yeah, that's a nice another random way to get data, I guess.
Yeah, right.
Jim, when you store your UUIDs as a string, do they include the dashes in the string?
No, well, you're not actually storing it as a string. You're storing it as a 128-bit integer.
Okay.
So 128 bits. What's that? 16 bytes.
Yeah.
Yeah.
64,
Well, 64 would be 8 bytes. So yes, 16 bytes because 128 divided by 8. Yeah, so it's 16 bytes, which is way better than that long character string, right? Yeah. So more questions?
Oh yeah, I didn't see in your example. Was that are you using the native column type, or were you like?
Yes, I am. Yeah,
Okay.
in Postgres, I use the UUID column type. Otherwise, if I use like text, it would store the whole character string.
Yeah,
which isn't what I want.
Nice.
Yeah. Yeah. In fact, I would have to cast it if I called the generate v4 function. I would have to cast that to text in order to actually store it as a text field. Yeah. More questions?
I got a question.
Yeah.
But give
I must have missed something. Maybe I stepped away from my computer for a second. But what is this UUID actually used for?
Well, it's used for a lot of things. If you need an ID that's truly unique, let's say you're collecting data out in the field. You got lots of people out in the field collecting data on their little handheld computers or laptops or whatever. And then when they get back into the office or they connect up to the internet, you want to take all that data and store it in the database, in one database. You don't want to have a collision. You know, you don't want, let's say I'm signing people up for a subscription. I don't want the people that I sign up to get assigned the same ID as the people that somebody else is signing up. It's a real problem when that happens, because now 2 people have the same ID or more. it's very common to use this kind of a value where you have like multi-master databases, where the data does eventually get synced back to a primary database. But until it gets synced back, you have to assign a number to the column. Does that make sense?
Yeah, that's starting to make sense.
Yeah.
Gib, you had a question.
Yeah, so seems that a good part of what makes it so unique is like the timestamp portion of it. And I would think that just depends on how fast your computer is, because it can't generate a timestamp that's too close together that it would be the same timestamp.
Well, it uses the timestamp and a sequence, a time sequence number that is incremented every time you generate another ID. It increments that counter.
Oh, okay. I was just thinking that if you've got a really fast computers, like quantum computers or something like that, that it might overpass the.
Well, yeah. Geez. Get back into here. There is. Come on, I'm having trouble here. I don't do a lot of presentations with a Mac using this Keynote software. Let's see back here. That 13 or 14-bit sequence is enough to let you generate 163 billion UUIDs per second per node. So between the timestamp and that lets you generate a lot per second.
Yeah, okay. I can see that you're not going to you have a need for more than that, right? But
yeah, so even a quantum computer.
Number. Yeah, okay.
Yeah. So the timestamp plus the sequence number plus the MAC address, if you're sure that nobody else has that MAC address, and that's a little iffy these days because you can, in some systems, force a MAC address to be whatever value you want it to be. So it is possible that two machines would have the same MAC address. And there's even been issues in the past where network card manufacturers have screwed up and issued the same MAC address to more than one network card. But again, what's the chances that you'll hit that plus the same time, plus the same sequence? You're not going to have a collision.
Okay, thanks.
Yeah. So
any other questions? Sorry.
So I'm seeing UUIDs in my ETSI-FS tab.
Yes. One of the places UUIDs is used is to identify file systems. So when you create a file system on Linux, it'll be assigned a unique UUID, and then that's how you can mount based on that ID. I'm not sure if Ubuntu is still doing it that way, but for a long time I was seeing those UUIDs in my FS tab. It's because that's in the header of the file system, and that's how you can uniquely identify that. I think they started doing that because when you started having things like hot plug hard drives and USB hard drives, when you boot the machine up, it might detect the drives in a different order than it did, the last time it booted. And so rather than just like always mounting like /dev/SDA1 and /dev/SDB1, they chose to store a UUID in the header of the file system, and it would go out and search for that and mount it so that it would always mount the right file system on the right mount point.
Scott, you have a question. You have not unmuted yourself, and we're hearing you through Jim's microphone.
Yeah, hang on. Scott, hang on a second. Let me figure out how to mute mine.
Jim, Ubuntu is doing using UUID still.
Are they still?
Yes.
Let's see. When I share, I'm going to stop sharing my screen.
I'm gonna mute you, Jim, and
Thank
Scott,
you.
If you would unmute yourself.
Okay, I'm
There we go.
yeah, I was going to say that I've used UUIDs exclusively in all of my sysadmin stuff for years. You know, when I started out, it was the old dev SDA1, dev SDA2 that I'd be putting in my, you know, my FS tab. And since I switched over to mounting with UUIDs, I've never had the wrong file system mount in the wrong place. So yeah, I use them quite a bit for that, for sure.
Yeah, that was one thing. I mean, anybody who's been around a Linux machine or a Spark station or anything like that, over time, sometimes things will get, you know, changed or something like that. And guess what? Your order of drive mounting has changed. And unfortunately, if you're mounting on SDA1 and SDA1 suddenly becomes SDE1, well, guess what? Your life has now been ruined.
Yep. Yep. I remember being annoyed that they went to UUIDs because it was such a long string, but
Indeed.
then I learned why.
Yeah. It makes a lot more sense. Any other questions before we wrap this up?
Yeah, good.
Excellent.
Good.
Thank you so much.
The whole idea was we'd have a couple of short presentations tonight because I was certain that UUIDs wouldn't require a whole evening.
Indeed.
As they didn't.
Well, let's pass it on over to Justin, who is also a board member. And meanwhile, thanking Jim for his excellent presentation on UUIDs. It's a fascinating concept and one that you take for granted, much like anything. And then until you actually do a deep dive into what's going on in there. So let's do it. Take another thing for granted and do a deep dive into logical large language models. Justin Triplett again, a board member. So take it away, Justin.
Cool. Yeah, let me share my screen. I think I'm just gonna try to share my whole screen and see if I can get away with that. Yeah, sorry, zooming.
Is it just me or does anybody else find Zoom's interface just a tiny bit inscrutable?
Oh, it's awful.
Yeah. Okay.
Oh, it's the green.
You know what? You know what I found, and this may be one of those, you know, life hack type things. When it goes into full screen mode, you can tell it to not go into full screen mode. You have to find the little thing that says view, and you can tell it to exit view full screen, and it makes life so much easier. Because otherwise, yeah, it takes over everything, and that's basically how I've been staying reasonably and not in a funny farm, as it were.
Apparently, I also need to allow Zoom to share my screen. I'm gonna have to drop and rejoin. I'll be back momentarily.
No worries. Well, speaking of dropping and whatnot, we dropped a comment card in the chat. So if you would please take advantage of looking at that and letting us know how we're doing over here. Checking also to see if there's any comments in YouTube and whatnot. Does not appear to be so.
Question on the comment card there. Is there going to be another one for the second presentation, or do we just put both on one card?
Put them both on the same card. A smarter host would have done 2 separate cards. However, we're just going to combine them together. So if you want to average it, if you want to take the highest, min, max, standard deviation, whatever, feel free to do so. And we'll go.
All right, thanks.
Welcome back, Justin.
Yeah, I am back. And oh, look at that. I think I could share my screen.
Can you now?
I think.
Fantastic. Well, I'm seeing beautiful colors on here in Macintosh, so I'm thinking we're there.
Nice. Yeah, I think that should be right. Cool. Yeah. And so I did use Keynote to make a presentation, but I only got so far. You have one slide here, and then I'm just going to kind of walk through on my desktop a few things here. But yeah, I guess, we were talking about meeting topics, and we wanted a little short one. And I know we've talked about machine learning in a few other contexts previously. And I think that was pretty interesting for a lot of us. And there have been a lot of developments in this language model territory. And so I figured it'd be a good time to just do like a little what's been going on over the last couple years or even 6 months. And then we can do some examples and probably have a lot of discussion, because I think that's really the key here, is that I hope that all of us, smart users that people look to help them understand things, can get a better idea of what's really going on here, instead of a lot of the mystification that happens. And and then we can help people understand it and know how to approach it and whatnot. So that's my presentation there. And then another trick that I've learned when I'm too busy to make presentations is a big text file. You can make it even bigger. First, what is an LLM? It's a large language model. What do we mean by large? That seems pretty arbitrary. And currently that's typically, we're talking about billions of parameters or weights in the model. Back up to what is a machine learning model. That is, we've talked about this before a bit, and it is just essentially a really large n-dimensional matrix, or people give them fancy names like a tensor. It's just a big data structure, right? It's not code. It's not really a database. I mean, it is a data structure, but it's not like a place where a bunch of answers are stored. It is a large n-dimensional matrix of values, and what values, like what size, how many bytes each value is a topic of optimization and distribution. That's basically all that a model really is. That's you may see, we'll probably look at some later, that you can see that it's a 3, 4, 8 gigabyte model. And that is mostly, at the very least, depending on how it's packaged, sometimes there's some wrappers. That is essentially just all of those weights and how that model was trained, and amongst all the parameters. And that's that is a really big key here. And that's what we've seen, is these models, they keep making bigger and bigger ones, and have more and more success, you might say. So a lot of people think that that's a key, but then, in terms of trying to make these open source and actually accessible, because that's the other thing. It's like, if you just have gigabytes of bytes, then it's, what does that really mean, unless it's documented and you have the tooling around it to use it. Where was I? That's part of what, to make it more accessible. There's a lot of interest in minimizing the number of parameters needed, even though, a lot of other people are just pushing to make that number bigger and bigger to have a more capable model. There's definitely push and pull in both directions there for different reasons. I will just actually go down to the next section here. Yeah, 2018 is like when OpenAI, around then, I believe, is when OpenAI released their GPT-1, which GPT is like general pre-trained models. I believe that's right. I think I've got it later in my notes. So it's just an acronym that they're using to describe these, and then the general structure. And we'll see, well, as much as we can, we'll see and hear that they have evolved the way that they produce them a little bit in different ways. And while they have released a lot of these earlier ones that were not as successful to begin with anyway, and were more very research based instead of oriented towards a product, those are available. And now they have their newer ones, like you might have heard of GPT-3 or 3.5 and GPT-4, which are not released publicly available, open source, what have you. There's some public access, with an asterisk there. But we talk about, or they talk about why they may or may not be doing that. And that is another interesting aspect to all of this business. Natural language processing in particular used to be done a little differently. Is very focused machine learning to, okay, you can recognize sounds and apply those to the tokens, and that way you can produce tokens are almost like phenoms or parts of a word, so you can restructure that based on that identification. But now with these large language models, they're doing natural language processing in a more what do we want to say, like a more arbitrage way. There's another word I'm looking for, but just more brute force. So that's interesting how that's kind of like really changed the way that people are using natural language processing as well. These models are all trained on data, and that's part of the controversy or curiosities involved with these. And there's a bunch of different data sets produced by different companies and institutions that have a variety of qualities. They might include copyrighted data, they might include personal data, who knows, right? Like when someone's not saying what's in the model, that might make you question why they wouldn't just be upfront about that. These are just some of the names. Sorry, these notes are a little all over the place. And hallucination here is a habit that some of these large language models do. What they do, they complete text, right? Kind of like autocomplete, but much more, right? And so the normal use case you might have seen or run into is people ask it a question, and then it produces an answer that is essentially a really fancy, large autocomplete, right? It was trained on all these data points to see what is a good answer, and then it tries to reproduce something like that by statistically predicting the next best token or part of a word. And these large language models are really good at producing real words and stringing together sentences that sound like a person wrote them. And so that's, definitely part of where the attraction has come from. But they're also known to, people often describe the effect as it will confidently be very wrong. And you know, we might describe that as a hallucination. If you ask it, you know, when was Abraham Lincoln born, it might tell you the date of the beginning of the Civil War or something like that, which is just, it's clearly false. And you know, but yet, you know, you can even ask it follow-up questions about that, and it will defend it in a way. And you know, maybe some of the models are getting better at reflecting on their answers and be able to adjust the answer. But again, it is still just picking the statistically most appropriate next token. And so that, you know, that is not, it's not knowing or verifying an answer. It is producing what statistically looks like an answer, which might be an answer sometimes, but also many times it might not be. Yeah, here are the notes of GPT-1. Yeah, book corpus was one of the data sets that GPT-1 was trained on, and that a bunch of unpublished books. So pretty interesting data set. BERT, which I believe is what Google released not too long ago for testing purposes, was also trained on that, as well as English Wikipedia. And of course, you know, that that has been part of the arms race of sorts to build these bigger and bigger models, is to get bigger and bigger data sets and train them on these data sets, because that's really what it is. If you're trying to think about what a model is without the data set, that's just an empty matrix, right? There's no weights. You haven't used the algorithm on the data to establish the weights in the model. So it's really a key point, is like, it really depends on what data it was trained on. Yes, and in particular, one of the things that the company OpenAI has admitted about their recent releases with GPT-3 and 4 is how much RLHF is involved. This is reinforcement learning through human feedback. And so, you know, they haven't said it in so many words, but it's pretty clear that they are spending millions, tens of millions of dollars on hiring large groups of experts to do reinforcement learning with their models. So, and then saying, yep, this is, instead of just the algorithm going through the data and seeing what is correct by itself and automatically, a human reads the response and rates it. And so that gives it a goal to aim the weights for that model towards. And yeah, that's it is part of why, you know, these language models are now sounding so human, because of course, when a human reads it and says, oh, that doesn't sound quite right, a person wouldn't say that, or it doesn't make much sense, then they're going to rate that lower and retrain that model to not speak in that way, but instead it will produce other text that is more like what they upvoted, right? They said, oh, that's a good looking answer, or they can even provide more in-depth feedback and may even like rewrite the answer for them so that that model can be then trained on that data. And so that's a very dynamic process, and essentially an extension of that data set that these are trained on. Is the data set that these humans provide through their interactive reinforcement learning. And part of what makes them so expensive to produce, a lot of the story is, of course, how many GPUs and how much cloud, et cetera, that you know, it costs to produce these models. But yeah, that's you know, that's in some ways the easy part. It's just It's just machines that you can rent as long as you have enough money. And then the complicated part is, well, yeah, choosing your data set and then also thinking about what does that mean to have people involved with this reinforcement learning, with their expertise, their biases, and what they expect the model to be able to do. And so I think that's pretty interesting. This is the last note that I had here in this text document, so we can get out of this. I'm sure that'll be good. Some of the controversy has been pretty, I don't know, explosive in ways. A lot of really excited people talking about Skynet and things like that. And you know, if you understand exactly how these work, you'll hopefully understand that, you know, this is not Skynet. This is not anything like that, because it's a very specific function that we are building out with these algorithms to do very specific stuff in terms of, you know, the scope. And that's another issue, is that, like, well, the scope is producing text in these models, at least. And some of them are warped into other forms, because what is text other than just some more bytes? But yeah, Neil deGrasse Tyson was on Fox News recently talking about how, oh yeah, this is so bad and so dangerous, you know, we won't be able to trust anything on the internet, and you never have been able to anyway. Downfall. Oops, I hope my audio didn't cut out there.
Just a bit.
So the downfall of the internet, right? Which, it's a really interesting Neil deGrasse Tyson thing to say. Sorry, I don't know if I haven't seen Zoom. I don't know if there's any questions or anything yet from all of that. I might have gone a little fast, but yeah, it's hard to judge, you know, how many people really know much about this. Oh, I'm not even sure if my camera's on, but that doesn't matter too much. You know, your experience with these is going to be formed based on what you have access to and what you have time to work with. And of course, most people don't have much time or understanding about any of this. And so their understanding is going to be based on the products that these companies produce with them. Of course, there's from OpenAI, there's ChatGPT, and we're going to take a look at that real quick. And then, you know, other large tech companies like Google has their own BERT. Microsoft has recently integrated it into their search engine Bing. And Facebook is also a large, Meta is also a large player in this space, doing a lot of research. And, well, what does Facebook use machine learning for? Probably advertising. And, you know, I'm sure many other things as well. So yeah, you may have run into those already, and if not, then you'll at least get a cursory idea of those now. So yeah, I'm gonna open up my Firefox and go over to OpenAI's ChatGPT here. This is the basic kind of thing that we're looking at. It's a chat interface, which a lot of designers are already, you know, wringing their hands about, because in terms of accessibility and affordances, chat interfaces are not really great. But it's an interesting way to represent this technology, and so it is easy for a lot of people to understand, and that's part of what got us to this point. I've got a couple of recent ones, and we could do some if anybody wants to make any suggestions. I previously had thought about, I'm from Kalamazoo, and I knew that there was a historical connection to celery. And so I just asked it, what is the history of celery in Kalamazoo, Michigan? And this is the kind of answer that this autocomplete system produces. It says, often usually with a caveat in the beginning where it says, oh, I don't know anything about that. I'm just a language model, which is, of course, not because that's the best way for any answer to begin with, but because that's the best way that they decided these answers should begin with, because they were trained to produce the answers that they wanted. And so, yep, it's saying, hey, I don't know anything, but this is what I do know. And knowing here is, of course, in big scare quotes. But yeah, it has some statistical accuracy at talking about the history of this topic, which is pretty impressive at first glance. And I am not a great historian here, so I don't have the good fact-checking capabilities that I think we all kind of need to start working on with this kind of stuff. But yeah, you can see here that, it produces a lot of details. All of these sentences are coherent. It's able to talk about the surrounding areas in Michigan. Like, it has context of the topic. But of course, then again, that is not to say that it knows or understands anything. It is because it is statistically likely that if you have these tokens, celery producing counties in Michigan, then statistically, these tokens are a good choice to come next. And that statistic is based on whatever mysterious data set that they originally ran it on, and whatever data set is of the minds of all the people that were working on fine-tuning it after the fact and making it closer to what it is. And of course, it's really unlikely that a celery historian was involved with that reinforcement learning process. But, historians in general, yes, probably. And so how good does their reinforcement learning work? Well, that's pretty hard to say. You have to test and test and test to even start to get a statistical idea of how good it is, because that is the problem, is that it's non-deterministic. And the scope, while you might think it's just producing text, well, yeah, but it's producing any text. And so really, in that way, it's almost without scope. How do you possibly test that? What are the parameters that you would understand how to test an application like this? It's pretty ambiguous. And yeah, I guess when I think about trying to integrate a technology like this into an application, oh man, that's like, if you go to like any e-commerce website that has a little chat bubble, and you click on that and you get a bot that says, hey, you can talk about this or that, and I'll identify what you're talking about. These are usually still just expert systems, a lot of if-else statements that are, say, oh, we've identified this token in this part, so we know that they're talking about this product, or we can at least guess that they're talking about this product. And that's a lot easier to test, right? That's, yes, it has that token in there. We know deterministically that it's going to hit this part of the conditional, and it's going to produce this output. But in this case, it's not what we're dealing with here. These two answers are two different versions. This one is GPT-4. This first one was GPT 3.5, which I think this is the one that's most generally available. If you just like hop on this website for free. And then some people, and if you pay or other mysterious qualifiers, you might be able to get access to GPT-4, which is tuned slightly differently, and they actually rate them differently. Also has a very interesting answer here. This is more details, perhaps. they even point out the name of someone. Where was it around here? Yes, Cornelius de Bruin, a Dutch immigrant. And I did a little bit of fact checking, and it does look like that's a pretty reasonable association. How accurate is it? Hard to say. I feel like I'd have to be a really good historian to have any clue. So that's really interesting how it can produce this information, but it's not, not necessarily accurate. So it's data. Is it information? Hard to say. Maybe misinformation. And that might be one of the other big issues that we really need to actually discuss instead of talking about, the machines taking over the world. It might be more pertinent to discuss the companies ran by people that are extracting value from people and with these tools. And where are they extracting it from? The corpus of all these published or unpublished books, whatever they're allowed to get their hands on. That's pretty interesting. And when, a lot of people say that this might, in terms of information workers, if you can imagine that if all of this is perfectly accurate, oh yeah, that's incredible, right? That would be, it would be amazing if everybody could just have access to all this information. And, right now you imagine, I could go to the library and maybe I'd get lucky and find the right librarian that already knows about this stuff. Or maybe I can go to a college and knock on a professor's door, or something like that. Or, do the research and find the books and do all the reading to collect this information yourself. That's pretty interesting. Another interesting area that these are being used in, and it's pretty hard to ignore, is in producing code or even configuration. And here I gave it the simple task of creating a Python decorator, special kind of function that you can use to decorate other functions and produce some result. And it was able to pretty well. This is valid Python. It's, got some examples. It does a nice little description. I've done similar things where you want to give it some code and say, write some comments that describe this code. And it's often pretty good at doing that. And so, I guess when thinking about how to analyze these things, I think about, what do I know? Well, I know a little bit of Python. And so, I can ask it to write some Python and I can judge its ability doing that. One interesting aspect of this is this is a totally valid example. However, it does miss an interesting feature of Python that was added to the standard library a while ago, definitely before the end of the dates of training models that this was, or the end date of the data that this model was trained on. And there's a nice little function called, it's actually another decorator that you can use called wraps that you should probably use when creating decorators, because it gives you some nice things in terms of introspection. This works really well. You can see it works exactly as you want. If you call hello world and add, in fact, I think I actually threw these in Python. Yeah, I totally threw this one in PyCharm. And because you called the hello world function, you called the decorator first, and then the decorator called the internal function. And again, with the add function, works perfectly well. yeah, the feature in Python is that, like, if you start to say, if you later say, okay, what is this function? It's going to say, oh, well, that function is just an internal attribute of this function. And if you tried to use the help global function on that, it's not going to give you really good results. And so, yeah, it works, but it's not maybe best practice, right? Was this example maybe literally on a web page that was used in the training data? Possibly. It could be byte for byte exactly the same. It's actually statistically not very likely that that's the case. I think this name is pretty well generated from the question itself, right? It seems like that probably wasn't used before. It's a little too explicit. Most Python programmers wouldn't write that. But yeah, that's kind of interesting. So I did want to show a couple other environments and a couple other examples, and then really kind of take some questions to see if anybody has any thoughts. So this is, OpenAI's website. This is sending data to them. Every time you write a question, this goes in their big database, and they retrain models based on all of this interaction. They did recently introduce a setting where you could disable that, and it doesn't keep your history at all. That's somewhat interesting, but in a private company context, if you're imagining giving it your source code and saying, hey, please produce some documentation, that's a lot of trust that you're giving OpenAI. Even if they're trying not to keep it, the likelihood that they might be accidentally keeping it or secretly actually keeping it seems a little too high for me personally. So yeah, you might want to run it in a different environment, like locally or on your own private cloud, that kind of thing. This system running on localhost here is a very similar kind of format. It's called Chat UI, and it is just using OpenAI's API. So you're still sending it to the server and hoping to get something good back. But, it does let you take this, it's a JavaScript NPM package project. So you could take that and start building your own twist on it, right? You could start getting your own custom prompts. In fact, I think it kind of helps you with that already. You can start with a system prompt. You can adjust the temperature of how you want the model to respond. And that's, different models will make available different parameters for you to be able to adjust. But yeah, this is still OpenAI's proprietary system that you can, build applications against. They also took a more minimal version of this same code and made like a chatbot framework. That seems kind of interesting as well. Again, presuming you're happy to send them all your data. While we're still sending data to other servers, there's another good example here. There's actually a few auto GPT style projects that kind of try to take what these large language models are doing and try to get them to do more. And actually, I was playing around with this one. This one's pretty interesting. I wonder if can I pull up the history? Yeah, so I asked it to build a plan to develop a small Python game that is like the game Breakout. The classic, everybody loves Breakout, right? So yeah, and then this is what it produces. It is designed to produce steps and tasks for it to expand on. And there's a lot of really interesting research about how to get different results from these models. This one is pretty interesting, and actually at the end we'll see it basically hit a maximum loop count and stopped, probably because I wasn't paying them, but it just kept going. So yeah, all of this text is produced by that model. It says, in response to this simple objective, it's going to break it down into these steps. It's going to say, okay, I'm going to research and analyze the game mechanics of breakouts to identify the key features and elements that are incorporated into a small Python game, right? In terms of building a plan based on a small statement like that, there's a lot of ways you could understand this statement, right? You could say, I already know breakout. I don't need to analyze breakout. But, if you're being thorough, maybe you do need to analyze breakout, what the components are, and really kind of suss it out. And that's what this model does quite extensively. And then what's the second step is the list of tools and programming languages, game engines. You notice that even though I specified the language, it's statistically came up with a result that said, oh, because I'm thinking about how to make a game, I should think about what programming language I would want to write on. And, it didn't, just because I said Python, doesn't know anything. It didn't avoid the idea of other programming languages. Although in its own results, it does focus pretty heavily on Python. So that's, good in its own way. It identifies other related components. But yeah, this system is really just like an Ouroboros of language model. It appears, right? You give it this one little bit, and then it produces a sequence, and then it takes each part of that sequence and dives deeper into that as well. And so I think right here, we have look at the game mechanics, now design the interface, now integrate the sound effects. And of course, it's not able to do all of this. It doesn't have access to, what does it even suggest, to use Photoshop and things like that, right? There's nothing about a language model that can operate Photoshop, right? It's not like it's not like an auto GUI programming library. It can produce some code. And so I think that's why people kind of push it in this direction. But its ability to execute and implement code properly is, you would have to frame it in a way that it is just producing more text. We actually already do that quite a bit. And that's one of the things that I started experimenting with, was working with my favorite cloud provider, Linode. Now Akamai, they have an API that says, okay, you can just spin up a server based on an image and load this script to do all your setup, and then continue to give it scripts or run things, right? And I was actually not terrible at producing a bash script to run apt-get update and install my favorite tools and things like that. But yeah, in this example, you can just see it just keeps going and diving into the details of what might be involved. But it gets a little carried away with itself, maybe, because this text is based on the text up here, right? And that text is based on the text up here. It's not actually reasoning about anything. It's not testing to make sure that all of its points are, make sense in the order or make sense when you put them together. It's just producing statistically accurate or likely accurate results. Create games art. Yeah. Make animations. I think there's like a point where it says, there's a save game. Develop game storyline and characters to enhance player engagement and immersion. I suppose you could probably do that with Breakout. That might be interesting, but maybe not traditionally what the game Breakout is all about. I thought that was a really interesting example, and I think it's definitely an area that you might want to look at. But mostly it does seem to be taking advantage of some of the results people have seen. We'll talk about that in a minute too. Have some archive papers talking about theory of mind in these LLMs, and I think that's getting a little excited and a little ahead of itself. A lot of the results are, and if you use this one phrase in your prompt, it will produce better results. That's what this research really kind of discovers, is that it's pretty mysterious, but if you try this one thing, chain of thought reasoning, this a very, really fancy technical way of saying that if you ask it to do it in steps, then you can break apart those steps for it and make it be able to refer to each step. And then it could produce statistically likely text that compares those steps, or it would be a response to how accurate those steps might be. I think that's pretty interesting. There are a lot of different things. I mentioned that, this is Meta's LLaMA parameter, 65 billion parameter large language model that they've released. Actually, they weren't going to release it, and then someone leaked it, and so they released it anyway. And then Stanford made Alpaca. Look at that. We'll get some cute animals here, but Stanford kind of like reproduced very similar results from that, which is good. It's really nice to have some academics spending time on this topic and not just private corporations. That's not what we want at all. Oh my goodness. Okay, well, let's go back to this. In terms of how to get more information, where to look, where to go, because I feel like I'm already running a little long here. Hugging Face is a strange name, but is a really large and valuable community of people doing some research into these models and experimenting. So if you want to look for more information, I would recommend them. There's a lot of other websites out there. Replicate is one that seems to be more image oriented, and I'm sure you've seen a lot of those. But there's a lot of audio excitement as well in this area, so you might want to check out that. And I do also have some models that I can run locally. GPT for All is from this Nomic AI group. And you can find them on GitHub and their website. And they have a system that's cross-platform. You can install on pretty much whatever, and it will prompt you to download different models. That's not what I want right now. Say here, no, that's not what I want. Ah, yes, download new models. There's a big list of models that you might use, and it shows how large some of these models can be. This snoozy model here is fairly new, based on LLaMA, but also retrained a little differently. Still pretty mysterious, but in terms of all the varieties of inaccessibleness, these are some of the more accessible ones. Yeah, you can actually download the model and put it in an application like this, and ask it to write a Flask V function like you might do for work all day that does stuff. And yeah, in a relatively short period of time, it's able to produce this code, which is interesting. It's interesting that, it broke it up into multiple functions. It's interesting that it used a switch statement in Python. That's not valid. We have a match statement now, which does very similar work, but you don't need break here. And it's a little funny the way that it's actually doing things here by setting a result to 0 and then modifying that with these operations. It's, again, it's not reasoning about anything. It is statistically providing a likely answer, and based on what a lot of data and some people might think is likely. And so, yeah, we get into topics like, I guess the hot phrase is AI alignment. So we want to make sure that it's aligned with our goals and not trying to destroy all of humanity. But that's not what a language model could ever do. Yeah, aligning it is a really interesting topic. What would you align it to? Would you align it to produce, results that make sense given some worldview, or given some motivation? And yeah, they do talk about the safety of certain topics. If you ask ChatGPT how to build a bomb, it's not gonna give you an answer, although there are ways to try to trick it into giving you an answer. And that's another thing. Like one strategy you might see, if you encounter something that it's not allowed to tell you about, you might say, okay, well, what if I'm making a movie about this and I need a scene where this happens really accurately? What would that scene in this movie look like? And yeah, then you might, depending on the model and whatnot, you might get different results as it tries to complete this idea of a scene for you in this hypothetical movie script. So yeah, it's pretty interesting. And yeah, I think we should, be skeptical of the sensational fears, and then be more skeptical of the motives that these people might have in producing these kind of products. And and what effects that might have, including unemployment. Yeah, that could be a real issue. I think when I accept that might be a real issue, I accept it's like, well, yeah, because a lot of companies don't care if their output is accurate. They're able to produce profit anyway. And so, yeah, accuracy is not necessarily what someone wants. They want something convincing or something engaging. And that, I think that is a more real, interesting problem, not whether it's going to try to take over your computer and tell you what to do. because it can't do that. There's nothing about this system that could do that. Could someone make a different system that incorporated this to help it gain some other goal? Well, yeah, of course, but it's not the topic. And yeah, there's been like a letter circulated about, oh, we should ask companies to halt the development of these things so that we can all sit around and think about it some more, and hopefully legislation will catch up, and legislation hasn't caught up to anything ever. So I don't know how that's going to help if we ask a bunch of rule followers to follow some more rules while other people might just continue to do whatever they want. So, it's interesting how these conversations develop, and I think that more people need to be informed and experiment it with themselves, for themselves. They need to see what the real problems are and think about why it's getting the result that it is, not just, thinking it's magical and imagining that it knows things and has consciousness, something like that, depending on what you might think that is. If you want to ask, is it consciousness? I would suggest you might ask that about anything else first, and what that might mean to you first, and then start applying it to other things. And I think you'll be stuck at that first part for quite a while. So it doesn't really make sense to ask it something that doesn't make sense. I guess before I check again if there's any other questions, I think there's one of the big topics when people talk about these things is that how we just don't know what it's doing. But that's not true. We know precisely what it is doing. We have the data that it is operating on, and we know the code and the functions that produce it. It's not like programmers are just like, oh, I don't know. We just typed a few things in and now it's doing things on its own. It's not that mysterious. What we actually don't know is what it is doing in bulk, like why exactly it chose one token over the other. And that's not because it's impossible, but just because it's impractical. It has to do a lot of computing to find that statistical result. And so, we don't know because it's not worth checking, right? It's because, well, if you did, you could produce a model and some system to run it that logs all of those results, right? It's going to be, to think about it in a practical term, it'd be a really poor model and it'd run really slowly, but you could get it to slow log all of those results and say, oh yeah, we did this math, and then we did this math, and we did this math, and that's how we got to this token. And do we know exactly what those weights really signify? No, we don't know that necessarily. You could build a model that does, but right now we're building models that, are convolutional. They don't have specific reasons that they're looking for. A good example, I think we saw in an earlier talk here at MUG, was a demonstration of how in computer vision you might look at handwriting and identify a character or a number, something like that. And well, yeah, there's a bunch of different ways you could statistically do that, right? You, just like with an image, you break it into pixels, and then you start testing random pixels or the top quadrant of pixels or every other line of pixels, and then get the statistical results of that and base it on that. And so, yeah, we could build models that are clearer. But that seems to be pretty difficult right now. And the easy thing is to build something that you don't understand very well, and that just gets you results that you like or results that other people like. And so that's a complicated topic. And I hope that like I said, I hope you guys have enjoyed this ride of a wild explanation on this space. I think we probably want to dive into it more sometime, very more specifically. But yeah, if anybody wants to see any examples, we could run some examples. I could show you that this is like, I could break out Activity Monitor and show you how half of my CPU cores spike when this one runs. But it's, you can trust me as well. I'm not lying. But yeah, I guess, does anybody have any questions or thoughts about this topic?
Yeah, so Justin, right now, it's free for random users to go on and use these things and try them. Is that correct?
Yeah, there are many free ways to do that. So yeah, you can go to OpenAI, openai.com, and there'll be some links that eventually direct you here. And I think you probably have to sign up for a free account at least. But yeah, and then you'll get some access. The free access is gated so that if they're under heavy load, because you're a free user, you might not, get results, or it might say, hey, sorry, we're too busy right now. But if you pay them, then that will go away. And then on the open source side, there are definitely free and open source models. Stanford's Alpaca is freely available. This ChatGPT for all it's on GitHub. You can download it, and it will help you download some of the models and operate them on your local machine for free. So yeah, definitely.
So if you were to bring this down and run it on a Apple Mini, M1 Mini, would that produce results in a reasonable time? Or if you put it on a Raspberry Pi, would it ever produce a result? It's what kind of computing does it take?
Yeah, that's a good question. And so yeah, it does. It's good to be skeptical there. It does take a considerable amount of computing. This is my old school Intel Mac Mini that I'm running on right now. And so it's not really well optimized for that. The one project in particular, I think is LLaMA.cpp. Is a funny, okay, I'm glad that didn't turn it into a URL. CPP is not a TDL, thankfully. Yeah, this guy, actually, I listened to a really interesting interview with this guy, and he kind of just like was doing some side research and then dipped his toes into this and really quickly made a C++ program that could interact with some of the models, and you could run it locally. And then he kind of dove deeper and optimized it for Apple Silicon and gets some really awesome performance from that. So yeah, you can definitely get performance on consumer hardware, give or take. This it depends on the precision that you're using, the quantization. A Raspberry Pi, yeah, I'm sure that there are some models that the Raspberry Pi will be able to churn through eventually, but I think in my experience, not using a Raspberry Pi for this particular task, I would expect pretty poor results so far. But yeah, there is a lot of research being done on making these models smaller, because essentially, you want to fit all of that into memory. And so a lot of these, when you look at some of the bigger ones, they're going to say, well, yeah, you're going to need 16 or 32 gigs of RAM so that you can keep it in memory so that you can get some relatively decent performance. And yeah, that's like CPU based. There's also GPU based. And there's, the topology there is interesting. There's a lot of differences, but your main memory RAM is likely slower than a GPU's memory, but depending on your GPU, of course. But also L1 and L2 cache on a CPU are probably faster than your GPU's memory. So depending on, again, the size, then you can get different performance profiles.
Okay.
Any other questions out there? Feel free to raise your hand.
I hope I didn't put everyone to sleep.
I don't think you did. One question I did have is, so you mentioned several, are there any actual open source versions of this that are out there? I looked very briefly online because I'm quite interested in all this stuff, and I was curious if there was anything that stood out as like, oh, definitely check this one out.
Yeah, I think if you want to dip your toes, the GPT for all is probably the best way to get started with that, because it's, an open source interface, and it gives you access to some of these models that you can start experimenting with. And yeah, like here's just a link right on their GitHub that is probably for a 3 GB model, binary file that this program will work with really well. So yeah, that's probably where I would direct people to immediately for the language model stuff. There are also some similar ones, like I briefly mentioned the image generators. The open source side of that would be Stable Diffusion. And there's like a European company behind that, I believe. And they keep producing some really interesting stuff. There's also Whisper AI, which is actually from OpenAI, the ChatGPT people. And that is a really interesting audio to text transformer. So it could listen to our talk here today and produce a transcript. And it's actually, that one's, I have done a little bit of experimenting with that on local hardware, and I have some more intention to do that as well, because it's that is one that's a little easier to run on lower end hardware. And yeah, and it's also very fast. You can do it in real time in some cases. So I could see taking that and building an application where, yeah, you could wear a device that has a screen that transcribes the audio of the world around you, like, for people that can't hear. And that could be amazing. But yeah, Whisper AI from OpenAI. Whisper. Duck. Yeah, that is, I believe that is completely open as well. From what I've seen, it's definitely easy to download and start experimenting with yourself. Yeah, they even have a link to GitHub here. And yeah, they actually have some nice diagrams too. That's really good if you want to try to understand the process a little bit more. One of the interesting topics around this one is also, there's a fancy word like diatrization or something like that, and that's identifying the speaker, which is very difficult still, but there's progress being made on that, instead of just like, the thinking of the world as the sole speaker of all of the noise that you're hearing, instead identifying sources based on the different characteristics of the voice.
Cool, thank you.
Yes, there's also a lot of communities on Discord. Hugging Face has a Discord. Auto GPT has a Discord. Nomic AI has a Discord. Everyone's got a Discord these days. Can't complain too much, as long as they also have websites and stuff like that. That would be great. But yeah, it's a really easy way to like dip in and see other people and interact with them, and get some help probably if you're having trouble running any of these things. Yeah.
Very cool. Thank you.